Hello. Our purpose here today is to show some of the basic characteristics for identifying and categorizing various rocks. The intent is to hopefully show some of the basic characteristics that we use and to look at some really beautiful rocks. So without further ado, let me turn this around to our lab here. All right. We are going to start with some igneous rocks. And I have a couple of igneous rocks here that we're going to work with. And we're going to start with this one here. And this, one of the things I want to talk about in terms of igneous rocks is that in general they're formed from fire. Igneous means fire, if you will. And they're formed from magma or lava, magma being under the earth, lava on top of the earth. And depending on where the rock is formed, you get different forms of the rock. These igneous rocks are classified by their texture and their composition. And texture isn't how it feels, it's how it looks. What texture do you see? So for instance, in this one, you can see there's lots of grainy particles in here, and there's some really clever shiny ones, but they're also, if you will, grains within this. So we would call this probably medium to coarse grained as a texture. And when these grains form, it's an indication that this cooled underground where it had time for the crystals to form. The dark color is an indication that this is likely very mafic material, has a lot of magnesium and or iron, and that it was formed without being mixed with more felsic things, which would make it a lighter color. In addition to the color and the graininess of this, these crystals are quite interesting because they indicate a cleavage. And I have one really cool one up here that I think shows this almost perfectly. This crystal right up here, if I get it to reflect for us, I had a reflection, but anyway, there's a reflection on this side and another one. If you just rotate this 90 degrees, there's another one. So there's basically cleavage in two directions, two-dimensional. And that would be a classic. There you can see it really good there. And then if I turn it, there's the other one right there, the other cleavage. Anyway, gabbro, the two cleavage, the dark color, the grayness, gabbro. Now let's look at our other sample here. And this one is porphyry. And the interesting thing about porphyry is it has different types of particles in it. So if you look at this one, and I'd like to get over here, I have my favorite crystal in this one I like to work with. You'll notice there's these white items here, and then see there's some black particles as well. They're kind of a little shiny, or maybe they're obsidian, I don't know. Might be a mica. But the size of these crystals indicating that they were formed underground, had a long time to form up. But if you look around this, and these are particles here, these dark ones, but they're all set in this very fine gray material. Now, fine texture would indicate very fast cooling, no time for crystals to form. So this is an indication that this rock was formed in two different steps. That's what makes it porphyritic. And so the first step were these larger crystals forming slowly underground, and then as it was expelled, most likely, it cooled very quickly. So these crystals that were in there cooled with the lava, the material around it very quickly, and made a very fine thing. And that would be very characteristic of porphyry. The color on this, by the way, is a little distracting. This is actually a mafic material, which should be dark. And then I realize these are dark. But this one's fairly light, so it's a little bit distracting. Now, I did want to take one moment to show you another igneous rock here because I like the contrast. This is granitic. And the thing here, you can still see that there's plenty of crystals here, and just like there are here. But the interesting thing about this, you've got this gray matrix around there. You don't see any of that here. Even though there's different color crystals, they're clearly separate ones, but they all just mash up to each other. So that really sort of distinguishes, if you will, porphyry from, say, granite and some other things it might be. Okay, those are our igneous rocks. Let's move on to sedimentary rocks. Sedimentary rocks are formed generally in one of two ways. We talk about the what we call a clastic rock, which is typically formed by some form of weathering that breaks down the original bedrock material, and then it gets eroded, moved, and then the particles settle down, and through a process called lithification, they become settled, compressed, and then cemented together. But the key thing with these is that the grains are visible, and they're classified by grain size, and they're called clastic. The other way of classifying sedimentary rocks, because they're formed different, is when they precipitate out of a liquid. And when that occurs, these are classified by mineral composition, not by grain and crystals. So we're going to start with this, which is limestone. And this is kind of fun. And to save some time, since I knew it was limestone, I went right to what we call the fizz test. And what the fizz test does, you put a light acid on here, and if it fizzes, it means that that's calcite in there. And there's only a few really types of rocks that have calcite in it. Well, there's maybe lots of them, but they separate out into a few things. So we'll put a little drop on here, and look at that. Isn't that a great little reaction? This is not your vinegar, by the way. I made my own mild HCl by diluting down some muriatic acid, so I get that nice reaction. So this puts it in the calcites, and then figuring out which one it was, that narrowed my search down. I did it by process of elimination. So there's no shells in here. There's no oids in here. And there's no really clear crystal structure. You can see some crystals here, but there's not a really clear structure. It's kind of mushed together. So I wouldn't call that a clear crystal structure. And there's no conchoidal fractures. And each of those, by eliminating each of those, it sort of narrows us down that this is the limestone, which it was. Okay, now this one I thought was pretty hard for me to identify. This is sandstone. Well, it's becoming easier as I go through this. This is a sandstone, and it's got a very fine, gritty texture, both physically and in appearance. And I'm going to put it up. I think I have my magnifying glass here, but I don't think it works with the camera. I think the focal point gets fouled up. So I think if I move this up really close, you can see very close in little tiny grains. There's one there. You see they're all through here. They're there. And then they're just all pushed together. That would really make this a sandstone. All right. And last, we're going to move on to metamorphic rocks now. And I have two beauties here. I picked this one because I learned something in the course about this. And first of all, texture. So metamorphics, by the way, means change. They were some other rock before, and due to temperature, pressure, chemical, other things, they are changed into another rock. They're typically characterized in one of two ways, either foliated or unfoliated. Foliated means that it has layers to it, if you will, not separatable layers necessarily, but layers. And so take a look at this rock. It's got, first of all, it's got sort of a coarse, grainy texture. You can see the crystals in there. And then if I just hold it back a little bit, look, here's a dark layer, a light layer, a light layer, a dark layer. There's light, a little bit grayish, but still darker. Here's some more white. And so it's clearly layered, or it's foliated. And the black and white is very, very characteristic of gneiss, which is what this is. The other characteristic is that it's often folded or wavy, and you can see a little, if you will, a micro fold in here. So it's not straight, there's these curves in it. And if you had a large sample of this, you could see more of that folding. Okay, that's nice. Now, let's look at perhaps my all-time favorite in this group is marble, and this is clearly not foliated. There's no lines of any kind in it or different colorings or anything like that, just pretty much random, but a beautiful random. If you can see those crystals in there, this is a fairly coarse textured. See, there's a nice crystal there. Look at that one there. I mean, they're just all through here. It's just getting some of them to show out for you. There's a beauty there. Anyway, all these crystals that are in here together. And one of the real telltales here is not only the coarse grained crystals, but the sugar-like appearance to it. So it really does look like sugar crystals, and that is marble. Well, I hope you enjoyed this little lecture. I hope you learned something from it. Have a great day.